Today we're going to be discussing SQL, aka SQL, which stands for Structured Querying Language. It's a domain-specific language for managing relational databases that was developed by IBM in the early 1970s and commercially launched in 1979. There are a number of different dialects, however what we're going to be covering today is true of all of them. The pros, it's very widely supported and easy to learn because it makes use of natural language where possible. It's good at handling large data. It's much faster retrieving and aggregating data than, for example, Excel. It has built-in access management controls. It does, however, require you to have a lot of structure to your data and is less scalable than tools such as NoSQL. There are also some known security flaws, as was brilliantly satirized here by XKCD, so pause if you want to look at that for longer. There are many different types of query that you can run. You can create tables, drop tables, insert and delete entries. We're going to be focusing on select queries today as they are the most useful for retrieving and analyzing data. So a general select statement looks like this. You select some columns, some aggregates from some tables, subject to some conditions. You have group by clauses for the aggregates, and you have order by function in order to sort the data. I've created a little database in order to run through this. It's a hotel bar database with 3 tables, one showing beers, transactions and guests. If we run this script to select the data from the beers table, we can see the ID, the name, the brewery, the category, the type and the alcohol content. We don't necessarily have to specify all of the columns. If we want to just get all of the columns available, we can put a star in there, and if you execute that, you can see we'll get the same result. So imagine we only want the beers with alcohol content of less than 0.5. Imagine, say, we're driving. We can add in a where clause like that, and you can see it's returning now just the 4 entries with alcohol of 0. You can imagine further that rather than just alcohol content, we also want to make sure that it is a British ale, so we can add in an additional clause in the where area using and to specify British ale. If we execute that, we will see that we just get the British ale through. But imagine rather than just British ales, we just want any ale, then we can add in a wildcard character either side, and then if we run that, we'll get any beer that contains the word ale, and we can see in the results we get a Irish ale and a North American ale as well as the British ale we had before. There are many different types of aggregate. We can include a min, max, sum, average and count are some examples. When you include an aggregate, you should normally also include a group by clause in order to specify what to aggregate around, and you may want to include an order by clause in order to sort the results. You can see here we've got a query with a aggregate count function. However, the results it returns suggest there are 13 British ales. That's because we didn't remember to group by anything, but we can see that when we add in the group by category section and run it, it will give us multiple results for each of the different categories, and we can see that there's actually only 5 different British ales, but there's 13 in total. If we add in an order by clause, then we get the same results, but this time they're sorted from smallest to largest. You can also add in ascending or descending to make it order as you like. In order to retrieve data from multiple tables, we need to join different tables together. You can do this in 4 different ways. The diagram shows the data that it takes from each of the tables. We can see what this is like with an example. If we join the beers table on the transactions table, because the ID in the beers table is equal to the beer ID in the transactions table, then we get this, and we can see we've done an inner join, and we only get entries that exist in both tables, whereas if we do a left join, we get an extra 2 entries for when it exists in the beers table but does not exist in the transaction. This slide shows all of the different ways to select data that you may want from tables A and B using inner and outer joins, left joins, right joins, and some where conditions. Bringing that all together, if, for example, we wanted to know all of the guests staying in the hotel who have drunk an ale while they have been there, we can join the 3 tables together, use a group by and a whereby, and we will see that Margaret von Vonsberg has drunk
4 ales while she stayed, so she might want to visit our alien.